multiply a number, especially a single number, by another single number, the process is easy enough. We can quickly tell what the answer is. And what is more, there is always one way of carrying out such number operation. The same thing is applicable to division. That is, when a single number divides a single number, the process is straightforward and the answer can be gotten without much stress. And again, there is only one way to get that process done. It is the default method. The method we get by means of interpretation are things are referred to as the default method. What if we are set to multiply a sum and the difference? Product set aside. Let us focus on the multiplication and division of sums and differences. If we set out to multiply a sum or to divide a sum, we perceive that there are some other ways we can approach the process. Some other ways we can approach multiplication and division of sums and differences. These are alternative ways of carrying out such number operations. What are these alternative ways of carrying out the multiplication and division of sums and differences? That takes us to the second lesson objective of this lesson, the law of distribution. In it, I explain, by means of carrying out numerical operations, how to carry out alternative processes for multiplying numbers which occur as either sums and differences. The same is applicable to dividing such number expressions. Please follow me as I explain alternative methods of carrying out multiplication and division of sums and differences. Let us now turn attention to the second law among arithmetic laws. It is the law of distribution, also called distributive law. It is dealing specifically with products and quotients of sums and differences. In the course of time, you see how those things play out. Let us take a look at this first number operation. Let us give the answer using two different approaches. This resembles what we saw at the outset, but this is here for its own purpose. It is 5 bracket 3 plus 4. We want to get the answer using two different procedures of evaluation. First, let us use the default method, that is pre-selected method, the method that had been selected to be the method applied for solving this type of problem. 5 bracket 3 plus 4 simply means 5 times whatever the bracket contains. Of course, the bracket contains 7. I hope you know why. By now you know, I believe. 3 plus 4 is 7, then times this 5. That will give us this 5 bracket 7. So 5 bracket 3 plus 4 means the same thing as 5 times 7. So what then is this asking us to do by default? It is simply telling us to multiply 5 by whatever the content of the bracket is. That's the reminder. Let's continue. So 5 times 7 is equal to 35. And so this result came by default method, a method that had been known by many as what should be done to this number operation. Let us get the C35 using alternative procedure of evaluation. Let us at this point try to multiply the contents of the bracket one after the other. Before I proceed, notice that this 3 plus 4 is a sum, and it is this sum is multiplying a number. So if that number 5 multiplies the sum, we can call the result product of sum. Product of sum. So here we are dealing with product of a sum. Now let's continue. In how many ways can we get the product of a sum? First, by default, we got that 5 bracket 3 plus 4 is equal to 35. Then, alternatively, 5 times 3, see it here. 5 times 4, see it here. 5 times 3 is 15. 5 times 4 is 20. So, this 5 bracket 3 plus 4 will now become 15 plus 20. The result is still 35. This by default, and this answer, 35, came through alternative method. Is this a coincidence? Anyway, try and pick other numbers to replace 3 and 4. Numbers which are not variables but constants. Just use them and replace these 3 and 4. You can even replace all the 3 numbers outright. And you can even try to make the numbers in the bracket more than 2. Here we have only 3 and 4. You can just have 3 plus 4 plus 2 or whatever times whatever you see here. Please confirm that this second procedure is just correct and the answer that came to be did not come by chance. Instead, it always works. What it means is that when we are looking for the product of sums, this is a method and this is also a method. What if we replace this plus with minus to indicate a difference? Let's find out. And here comes that challenge. 4 bracket 7 minus 2. In this case, the numbers in the bracket are now joined, not in a sum, but in a difference. Don't forget I said earlier that the numbers in the bracket must not always be 2, as we are seeing in example. We can have more than 2, and yet what is observed here is observed in every other case, as long as what is contained there is sum. Also, in the case of difference, the same thing plays out. Let's see. 4 bracket 7 minus 2. This is product of difference. Product of difference. 7 minus 2 is a difference. 4 times that difference will give us the product of the difference. Therefore, 4 bracket 7 minus 2 is product of difference, while 5 bracket 3 plus 4 is product of a sum. Let us check whether the same thing is observed when we apply default method and alternative methods of procedures carrying out these number operations. Let us look at the first method, the default method. What are we told to do here? By default, what we mean is that we multiply whatever the bracket gives by 4. What will the bracket give? The bracket will give 5 because 7 minus 2 is 5. See it here. And this 4 is still here. So this 4 bracket 7 minus 2 means the same thing as 4 bracket 5. And 4 bracket 5 means 4 times 5. And 4 times 5 is equal to 20. It therefore means that by default, this number operation produces the answer as 20. Let's use second method, which is approaching it from the standpoint of using the number outside, a common coefficient, a common multiplier, to multiply the contents of the bracket one after the other. Let's see. 4 times 7, that is 4 bracket 7. Then minus 4 bracket 2, see it here. So in the end we have 4 times 7 is 28, 4 times 2 is 8. So in the end, 4 bracket 7 minus 2 will give us 28 minus 8. The result is still equal to 20. With default method, the answer is 20. And now, with this latest alternative method, the answer is still 20. If you choose any other difference to be in this bracket, and choose anything else to multiply the difference, and you choose both default method and this alternative method with this pattern, you will see that the same conclusions will be reached by you. Please try and confirm that these things are not coming by chance. Just pick your numbers and try carrying out these number operations in like manner. At this point in time, we are through with carrying out numerical experiments with products of sums and products of differences. What about quotient of sum and quotient of differences? Let's find out. And here, this set of numerical experiment comes. We are now talking about quotient of sums. Again, quotient of sums. Don't forget that quotient is an answer you get after division. So if we use 3 to divide 12 plus 15, the answer we get is called the quotient. Notice that this 3 is dividing a sum. This division could also be called quotient. This 9 could also be called quotient. So when 3 divides 12 plus 15, the answer we get is called the quotient of 12 plus 15 with respect to 3. At this point, let us get the result of this operation by default, and later we apply a perceived alternative method of solving it. Let's find out. What are we supposed to do by default? Here, we are supposed to first of all find the value of 12 and 15. And after we do that, we'll discover that the answer is 27. We now divide the answer by 3, which means this operation means get the dividend as one number and divide it by this dividend, which is 3. The dividend has two numbers in it, 12 and 15. Condense them to one number. See it happen here. Let that one number be divided by this divisor, which is 3. See it happen here. So when 3 divides 27, the answer is equal to 9. So the result of this number operation by that default is equal to 9. If we apply a different method or a different procedure to carry out this number operation and we get the same answer 9, then that becomes alternative method, especially if it works all the time. Let us see whether we can see a different method of doing it. Please, instead of waiting for 12 and 15 to join to form 27, we can just try dividing 12 and 15 separately. That is, let the effect of this tree be distributed to 12 and 15. Let us distribute. Let 3 divide 12 and let 3 divide 15. See it happening here. So 3 dividing 12 and 3 dividing 15. When 3 divides 12, the answer is 4. When 3 divides 15, the answer is 5. So the thing has become 4 plus 5 and the answer is still 9. It means that with this method we got 9. With this method we still got the same 9. The two methods are different and yet the answer is the same. This method doesn't work all the time, but this one works all the time. When variables replace any of these, or when a variable replaces any of these numbers, this first method begins to give trouble, but this will always work. Please confirm that this will always work by picking any other two numbers, not just 12 and 15, and then divide by any other number you like. If you like, use 3, if you like, use 4, but the main thing is, at last, please compare the results you got by default and the results you got by that second method. In the end, you will see that what I'm saying here is not coming by chance. Therefore, this quotient of sum is solved in two ways. One by default and one by distributive method, which is allowing the divisor to affect both numbers which form the dividend. Now let's consider quotient of differences. Quotient of differences. And here comes the example on quotient of difference. 40 minus 30 all over 5 can be evaluated in two different ways in like manner. Don't forget that the first case was a sum, quotient of sum, but this is a quotient of difference. 12 plus 15 is a sum, but 40 minus 30 is a difference. In both cases, something divides the result. So by default, let us see what 40 minus 30 over 5 will give to us. By default, the instruction is condense 40 minus 30 to one number, and that one number divided by 5. Please, if we condense 40 minus 30, the result is 10. And then let 5 divide by 10. That takes us to 10 over 5. When 5 divides 10, the result is equal to 2. Therefore, by default, this number operation gives us these 2. Let us apply the method of distributing the effect of this divisor to all the numbers that make up the difference. It is 40 and 30 that make up the difference. Let these 5 individually and separately divide 40 and 30. And let us see if the same 2 is the answer. If that is the answer, then that will amount to what we call alternative method. So let's go ahead, please. When 5 divides this 40, see it here. When 5 divides this 30, see, that means that 40 minus 30 over 5 is the same thing as saying 40 over 5 minus 30 over 5. When 5 divides 40, the result is 8. When 5 divides 30, the result is 6. So 40 minus 30 all over 5 is the same thing as 8 minus 6. Again, the result has become 2. This method by default, this method is alternative, and yet both of them produce the same answer of 2. If you try to use other constants apart from 40, 30, and 5, you will find out that this conclusion is not by chance. In fact, it has been concluded that this method always works. Personally, I tested and I discovered that this thing always works. Try and pick other constants and then confirm the same way. So far, we have had many numerical experiments bordering on product and quotients of sums and differences. Let us see the summary of results. In that summary, we will not present the default method. Instead, we present the results of the alternative methods. Let us find out. And here is the summary of results following the numerical experiments we conducted. 5 bracket 3 plus 4 is equal to 5 bracket 3 plus 5 bracket 4, which is equal to 15 plus 20, and the result is 35. I hope you remember. Also, 4 bracket 7 minus 2 is the same thing as 4 bracket 7 minus 4 bracket 2, which means 4 times 7, 28, minus 4 times 2, that is minus 8. 28 minus 8 is equal to 20. Also, 12 plus 15 divided by 3 is the same thing as saying 12 over 3 plus 15 over 3. 12 over 3 is 4, and 15 over 3 is 5. So in the end, we have 4 plus 5, and the result is equal to 9. I also know you recall that 40 minus 30 over 5 was given as 40 over 5 minus 30 over 5. When 5 divides 40, we have this 8. When 5 divides 30, we have this 6. Therefore, 40 minus 30 over 5 is the same thing as saying 8 minus 6. The result is equal to 2. Permit me to make a conclusion from what we observe between the first number operation, that is between the first number operation, which is the main challenge, and the next line of action, which is the way of getting that number operation evaluated. Let me cut off the remaining ones to make things easier for us. From here to here, let me cut off. From here to here, let me cut off. From here to here, let me cut off. And from here to here, let me cut off. Because for us to do what follows, those parts may not be necessary. Please, let us see them cut off. And now what you see is a simplified summary of those number operations. With what we now see, we can make some deductions or conclusions. What conclusions can we make from this summary? First, look at product of a sum. See how it is evaluated. See product of a difference. See how it is evaluated. So we can combine sum and difference the same way, which means when multiplying a sum, how to get the answer is the same way we get the answer when multiplying a difference. So the same pattern is used to multiply a sum and to multiply a difference, which means these two can join in one conclusion. Likewise, look at how a sum was divided and look at how a difference was divided. The pattern of dividing a sum is the same pattern of dividing a difference. Therefore, the two, that is quotient of a sum and quotient of difference, can combine to make one other deduction. Therefore, in symbols, what do we say is the conclusion from the summary we have here? Join me as I write the summary in form of deductions, which afterwards will become law of distribution in symbols. Please watch out. And here come the laws of distribution in symbols. The first is this: A bracket B plus or minus C. Let this 5 be A. Let this 3 be B. Let this 4 be C. Then, since this thing works both for plus and minus, it means that if we are looking for product of a sum and product of a difference, the same pattern is used. This is why both are condensed in one law. So when a number is multiplying either a sum or a difference, the procedure is the same thing. What is it? Use that number, multiply the contents of the bracket, and in this case it is A times B, which is AB, and then plus or minus A times C. Please, that is AC. Yes, AC. So A bracket B plus or minus C is equal to this A times B, AB. A times C is AC. I believe you now know why plus or minus is here. It is because this is a summary of what happened both in sum and difference. Alright, what about what happened here and here? Like I said earlier, both can be condensed to make one law, and this is why we still have plus and minus here. Whether it is plus we have or minus we have, the law is that if this 12 or 40 becomes A, and this 15 or 30 becomes C, and this 3 or 5 becomes C, then a different way of carrying out the number operation apart from default method is that we divide both A and B with this C. See it happen here. That will be A over C, see it, plus or minus B over C, see it here. Does it mean that before this law applies that we must have only two numbers in the bracket as a sum and difference? The answer is no. I'm supposed to put dots here to show that we can have unlimited numbers in this bracket. For simplicity, we just chose two numbers to be in the bracket. You could have 3 numbers, 4 numbers. Whichever number you have, this approach always works. What is the approach? In this first one, use the number outside and multiply the numbers in the bracket one after the other, as long as what you see in the bracket is either a sum or a difference. If what you see in the bracket is a product, please don't do this. I repeat, if what you find in the bracket is already a product, do not distribute the effect of this A. But because it has been tested that if what is in the bracket is either a sum or a difference, that we can rightly distribute the effects of this A by using A to multiply the contents of the bracket one after the other. Again, the numbers in the bracket must not be 2. We can have more than 2, and yet this procedure is valid. The same applicable to this one. We must not have only 2 as dividend, and we must not have only 1 as divisor. To simplify the process, we chose one alphabet or one letter each or one variable each for the members of the sum and difference, and then the divisor. In all, it is this and this together that we refer to as distributive laws. Now let us state the law of distribution in words, capturing these conclusions. And here comes the statement of law of distribution in words. It states, when a number multiplies or divides a sum or difference, the result is the same if the individual numbers are multiplied or divided. I hope this captures the sentiment expressed in all the numerical experiments conducted and the conclusion we drew before using symbols. Now, the time has come for us to see more examples of number operations in which the law of distribution is applied. Please watch out. Now, these are more examples of number operations based on the laws of distribution. We have about 7 examples here. We have 7 brackets 2 plus 1. By default, we know that the answer is 21. But by applying law of distribution, we have it that 7 brackets 2 plus 1 is equal to 7 brackets 2 plus 7 brackets 1, and that will give us 7 times 2 is 14, 7 times 1 is 7. So 14 plus 7 is equal to 21. Next, that's number 2. 6 bracket 4 minus 2. This is a product of a difference. Unlike the first one, that was a product of a sum, both are condensed in one law. We remember. So next, what do we do? Applying it, 6 bracket 4 minus 2 is equal to 6 bracket 4 minus 6 bracket 2. 6 times 4 or 6 bracket 4 is 24, and 6 bracket 2 or 6 times 2 is 12. So this number operation has become 24 minus 12. So the answer is equal to 12. Next, that's number 3. 4 bracket 3 plus 2 plus 5. This example was selected to stress the importance of the fact that we don't limit the number of participants in the bracket. That is a sum or difference to 2. We can have more than 2. Here we have 3 numbers taking part in the sum of numbers in the bracket. We have 3 plus 2 plus 5. You can have brackets that feature more than 3 numbers in a sum or difference. All of them can be approached from the same perspective, from the same angle, the same approach. Right? So we have 4 bracket 3 plus 2 plus 5. As before, multiply 4 individually by 3, 2, and 5. See it playing out here. We have 4 times 3, that's 4 bracket 3. Then plus 4 times 2, that is 4 bracket 2. Then times 4, then plus 4 times 3, that is 4 bracket, 4 times 5, that is 4 bracket 5. 4 times 3 is 12. 4 times 2 is 8. 4 times 5 is 20. You add them together, the result is equal to 40. Therefore, this number operation is equal to this 40. By applying the law of distribution. So the effect of this 4 was distributed across all the members of the sum in the bracket. That is the meaning of that statement. Next, that's number 4. We have 9 bracket 3x minus 1 In this case, we have a variable. In fact, the laws, arithmetic laws, were invented especially for math operations involving variables. The reason is that the default method always works for pure arithmetic, but default methods do not work for algebraic arithmetic. So here we have 9 bracket 3x minus 1. With that law of distribution, what we get? First, we say 9 times 3x, that is 9 bracket 3x. Then minus 9 times 1, that is 9 bracket 1. 9 times 3x is 27x. And then 9 times 1 is this 9. Therefore, the result of this number operation is equal to 27x minus 9. Let's make progress, please. The example number 5 we have as 2y bracket c minus 3x. Let the effect of 2y, which is the multiplier or common coefficient, right, multiply the contents of the bracket. In the bracket, what we have is a sum, is a difference. So c minus 3x is a difference. So let 2y multiply both c and minus 3x separately. Right. So we now have 2y times c. The breakdown was not given, but we can see that it is 2yc. And then 2 bracket 2 times minus 3x will give us this minus 6xy. This one tells us that we can bypass this stage and just come to this last stage. All beginners must not bypass this stage where what happens is explained. But as you become more and more proficient and become more and more experienced, you can bypass this stage and offer the answer. There is no penalty for bypassing this stage. So here I bypassed it and said 2y times c is just 2yc. 2y times minus 3x is equal to minus 6xy. Right, next, example 6, we have 15 plus 18 all over 3. And so we divide this 15 plus 18, which is a sum of numbers, by 3, the divisor. Applying the law of distribution, let the effect of these 3 be distributed individually to 15 and 18. That is the message. See it play out here. When 3 divides this 15, that is this 15, the answer is 5. When the same 3 divides this 18, see it here, 3 divided 18, the result is this 6. Please be very careful that you don't carry out the same thing I'm doing right here if the number operation is a product. If it is 15 times 18 all over 3, please do not insist on using this number below to divide them one after the other. That will be completely wrong. This is correct because it is the sum we are dividing. If we divide a product, its own law will come under the law of association. Until then, please be careful that you don't carry out law of distribution when you are dividing a product by a divisor. Right? The last one is 24 minus 18 all over 6. Let the effect of this 6 be distributed across 24 and 18. See it play out here. This 6 divides 24 and the same 6 divides this 18. When 6 divides 24, the result is 4. And when 6 divides 18, the result is 3. Therefore, 24 minus 18 all over 6 is equal to 4 minus 3. And the result is equal to 1. So far, so good. The time has come for you to test whether you truly understood the law of distribution. Please watch out for an exercise. And here comes the checkpoint. It says, apply the laws of distribution in evaluating the following number operations. Number 1, 10 bracket 2 plus 3. Number 2, 6 bracket 1 plus 7 minus 2. Number 3, 3 bracket 10 minus 3 plus 2. Number 4, 4 bracket x plus y plus 6. Number 5, x bracket 4 minus 2 plus 3. Number 6, 32 minus 20 over 4. Number 7, x plus y over 2. Number 8, x plus y minus z over 7.